Okay, practice test 3. Uh, there are 25 questions we have here, but in actual test there will be only 16 questions. Okay, so let's do this practice test 3. Problem 1. Evaluate the following indefinite integral. So this is a constant function, so indefinite integral would be, we know for the constant function, any constant function, uh, integration of constant function c, let's say not c, let's say k, would be k times x plus constant. This constant is for, this indefinite integral. So in this case it's a 10, so it should be 10 times x plus c. 10 times x plus c is some constant. Okay, this is x to the power 4, so we can use the power rule. It would be x to the power 5 divided by 5. That's the power rule for indefinite integral, and then there should be constant of integration c. That's the answer. Again, we can use this indefinite integral for the first one, and then second one separately. Again, we can use the power rule. Here is the x to the power 7, and this x to the power 7 on the denominator can bring to the numerator, and we can write it down as x to the power -7. So we can write down this problem as limit 8x to the power 7 minus dx minus 7 integration of x to the power -7 dx. So this problem can be written as this. Look, I just bring this 8 outside and then 7 outside, and I took this, I changed the position of this x to the power 7 from denominator to the numerator, and I made exponent -7. So now we can use the power rule for the first one, which would be x to the power 7 plus 1, which is 8. 7 plus 1, which is 8. That's the power rule for the integration. And this one is -7 plus 1, which is -6, and plus constant. So if we simplify this, it will be, we can cancel this 8 and this 8. So this is x to the power 8, and then this negative and this negative becomes positive 7 over 6. I can bring this negative 6, x to the power -6 down here, and I can make it like x to the power +6 on the denominator. So that's our final answer. X to the power 8 plus x to the power 8 plus 7 over 6 x to the power 6. 7 over 6 x to the power 6 plus constant. Okay, here we have given derivative of the function r, and we also have given the value of r at 1 is 44. We want to find out the particular antiderivative, meaning we want to find out the integration of this equation, and that gives us the value of r, but we don't want r, in terms of constant, general constant c. So we want to find out the value of the constant. This problem number 4, r is actually the integration of dr over dt with respect to t. So when you try to find out the integration, which is 104 over t to the power 5 of dt, we can bring this 104 outside, and we can write it down as a t to the power -5. And now when we try to find out the integration, it would be t to the power -5 plus 1. That is the general power rule plus some constant. So eventually it will be 104, and then this -5 plus 4 is -4. So I can bring that negative sign outside here, and I can write it down as t to the power -4 plus constant. So if you divide 104 by 4, that would be 26. So this is a general antiderivative, but we want particular antiderivative, meaning we want to find out the value of this c. So here r is function of t, which is negative 26 t to the power negative 4 plus c. But for finding the value of c, we have given one initial condition, that is the value of r when t is 1 is 44. So we're going to use that one. The value of r when t is equal to 1 is 44. So I can write it down 44 for this one on the left side, and then I can just replace this t by 1, so that will be negative 26 times t is 1, so 1 to the power negative 4 itself is 1 plus constant. So by solving this equation we can find out the value of c. So for that, just add 26, so that means 70. So by using that condition, initial condition, we found value of c, and now finally r of t is negative. Just replace that c by that value, which is 70. So negative 26 over t to the power 4 plus 70. So that is our answer. Negative 26 over t to the power 4 plus 70. That is the answer. That's the particular antiderivative. Okay, so let's go to next problem. Let's go to problem number 5. Find the equation of the curve that passes through 0.17 if its slope is given by this value for each x. So we have given a slope. So let's say this is problem 5. Let's say this is a curve, and there is a one point on this curve which is 1 comma 7. We want to find out the equation of the curve that passes through. Find the equation of the curve that passes through 1 7. We want to find out the equation of this curve which passes through 1 7, and we have given the slope of that curve. So we have given dy over dx, and we want to find out the value of y. So the only way to go back is finding the antiderivative. So we can find out the y is integration of dy over dx with respect to x, which is 15x squared minus 10x dx. So we can use antiderivative indefinite integration here for solving this one, for finding the value of y. So use the power rule for the first one. That gives us x cubed over 3 minus 10x squared over 2, and then plus c, which is the constant for that's the general antiderivative. So let's simplify this. If we simplify, then y would be 5x cubed minus 5x squared plus c. But remember, this is the general integration of this dy over dx, but we want to find out the particular curve which passes through 1 comma 7. So what does that mean is, we can just put x equal to 1 and then y equal to 7 in this equation for finding the value of constant. So when you put y equals 7 and x equal to 1, uh, that will be 7 equal 5 minus 5 is 0, so constant would be 7. So there is only one constant which satisfies this situation. So y would be 5x cubed minus 5 x squared plus 7. So that is the only one curve whose slope is 15x squared minus 10x, and also that curve passes through 1 comma 7. So the answer is 5x cubed minus 5x squared plus 7. 5x cubed minus 5x squared plus 7. Let me double check it. 5x cubed minus 5x squared plus 7. So this is on the exponent, so I need to take it down. Minus 5x squared plus 7. Okay, that's right. Let's go to the next problem. And next problem is again finding the indefinite integral, but this time there is a more than x. So we are going to use the substitution method here. So this is problem 6. Integration is find out the integration of 3x plus 5, sorry, 3x plus 8 to the power 5. So whenever we have this kind of situation, we can always substitute for this inner function, and then we can find out the derivative with respect to x both sides. That will be du over dx equal 3. So du over 3 equal dx. By doing that, what happens is this problem now can be converted into, just replace this dx by du over 3, and then this one is by u to the power 5. So look at here, the problem went from complicated looking a problem to the simple looking problem. So we can bring this 3 outside, so it is 1 over 3, and now we can use the general power rule for the integration. So that will be 1/3 u to the power -4 over -4 plus constant. That is the power rule, but we don't want our final answer as 3 times 4 is 12 in terms of u. So we have to put that value of u back as an interim of x, which is 3x plus 8 minus 4 plus constant. So this is our final answer. So negative 1 over 12 3x plus 8 to the power -4 plus constant. Let me double check the answer here. Negative 1 over 12 3x plus 8 to the power -4 plus constant. And that looks correct. One more time, this is also integration, as you can see, but you have to use the substitution rule. So substitute u equal 4 plus t to the power 7, and then find the derivative of that. That will give you t to the power 6 dt, and replace everything here in term of t to the in term of u, and then do the same thing like we did in previous problem. So I think you can do it, so I'm going to skip it. This is again one more time, you can let's do this one. It looks simple, but we just have to use log, integration of log, or log function. The derivative of log function is, so this is problem 8. I'm going to replace u equal 3x plus 2, then du would be 3 times dx. So that means dx can be replaced by du over 3. So this problem 1 over 3x plus 2 dx becomes 1 over u times dx, means it's a du over 3. So we can just bring this 1/3 outside, and now we have to find the integration of 1 over u, which is if you try to find out the derivative of let me see, derivative of ln of u, absolute value u, is 1 over absolute value of u du over dx. So that is actually 1/3 ln of absolute value of u plus constant. I'm using this absolute value sign because that u could be negative, so we have to make that positive. So eventually after finding this value, we need to plug a value of u back, which is ln u is 3x plus 2 plus constant. So based on the value of x, this expression could be negative, so we have to use this absolute value sign, which is 1/3 ln absolute value of 3x plus 2, and then finally plus constant. Yes, that's right. Okay, one more time. This is integration by substitution. Just replace this 4 plus 5x to the power 6 by u, and find out the derivative of u. That will be 30 x to the power 5 dx equal du, and then replace this x to the power 5 dx by du over 30, and then find out the integration like we did in previous problem. So just the substitution. One more time, this is also substitution method. You can substitute for x squared plus 6x plus 16, find out the derivative. Derivative would be on that would be x plus 3. There will be x plus 3. I'm just going to simplify this, and then I'm going to leave you do this problem. Okay, so in this problem, which is problem 10, I would substitute for the value on the bottom, which is denominator, and then if you find the derivative, that will be 2x plus 3, and then there will be dx. So sorry, 2x plus 6, because derivative of x squared is 2x, derivative of 6x is 6. So if you simplify this, if you factor 2, it will give you x plus 3 dx. And as you can see on the numerator, there is x plus 3 dx, but there is no 2. So what you can do is you can replace this x plus 3 dx by du over 2. So now this problem becomes integration of du over 2 for the x plus 3 times dx, and then u for the x squared plus 6x plus 16. So that will be du over 2 times u. So I can bring this 1 over 2 outside, and this is basically du over u, and then integration of 1 over u is ln absolute value of u plus some constant. So now if you put the value of u back, it would be half ln x squared plus 6x plus 16 plus constant. So that is our final answer. Half ln x squared plus 6x plus 16 and plus some constant. That's what we got. Okay, that's what we got. So check your answer. That's perfectly right. Let's go to the next problem. In this problem, this is the word problem. So let's read the problem very carefully. Okay, so in this problem, we have given the rate of change of cells S of t. So S prime means it's a rate. So to go from S prime to st, we need to find out the integration of this function. And also we assume that no cells at the beginning. That means the value of this cell s at t equal to 0 is 0. That will help us to find the constant. So let's go here and try to solve it. S of t, this is problem 11. S of t is integration of s prime of t dt. So which is basically 23 minus 18 e to the power negative 0.1 t dt. So let's find out the integration for the 23 is 23t, but integration of this function, if you know the integration of, if you remember this integration of a to the power x dx is e to the power ax over a. That's the integration. So here in this case a is negative 0.1, so that would be 18 e to the power negative 0.1 t over negative 0.1 plus some constant. This negative, then this negative becomes positive. 18 divided by 0.1 is 180, so that will give us 180 e to the power negative 0.1 t plus constant. Since we have given value of the cells when time t is 0 is 0, so we can use that fact here. So when t is 0 in this function, this part is gone, this part is 180, e to the power 0 is 1 plus constant c. So by using this equation, we can say, okay, constant c is actually negative 180. So by using that fact, for the first part, if we go down here, s of t, what is that? S of t is equal to 23t plus 180 e to the power negative 0.1 t, and then c is negative 180. So that is our s of t, 23t positive 180 e to the power negative 0.1 t, and then if you go here and find out, okay, that is negative 180, negative 180. So that's the value for the first part. For the second part, we need to find out the value of this function when t is 8. If you do that, if you just replace this t by 8, you are going to you have to use a calculator for that, and if you do that, the value would be approximately 8.989. So if you want to round it to the nearest what is that, the value would be if you round it to the nearest whole number, value would be 85. It's not okay. It's if you replace that t by 8 and then try to round it to the nearest whole number, it would be 85. And finally, to solve the third one, you have to just say, okay, cells on the left side it's 100, and then everything on the right side. And if you just plot that function using your graphing calculator, or use your something here on online, then that will give us the value of t would be approximately 8.99 if you try to round it to the 2 decimal place. Remember, for the third part, you need a graphing calculator. If you don't have graphing calculator, then that's not possible to do it. And if you are not allowed to use graphing calculator in the test, then that means you cannot do this problem. So this the third part can only be done with the help of graphing calculator. Okay, next problem, calculate the definite integral by referring to the figure with the indicated area. So we have a, b, c, d, and remember, if you try to find out the integration above the x-axis, that is area under the curve, and if it's below the x-axis, that's a negative of the area. Okay, so we know area of a is 1.408, area B is 2.5686, but since B part is below x-axis, while finding the integration we need to take negative of that area. C part is above x-axis, so that would be positive, which the value is given 5.692, but the D part is again it's below x-axis, so we have to make it negative. So eventually what happens is whenever you see the graph is above x-axis, just take that value, but if the graph is below the x-axis, just subtract that area, and then that will help you for finding the integration from 0 to c. Oh, okay, I almost did a mistake here. 0 to c means from here to here, so we don't have to worry about a, b, and then d part. So 0 to c is it's just the area, which is the area of c is 5.692. Where is that? 5.69 and 2. That's the area of c, and then that's what we're finding if you try to find the integration from 0 to c. What happened? Did I do something wrong here? Oh yeah, so my copy is not right. It should be 5.692, not 82, 692. That's perfect. Okay, this is exactly the same as the previous problem. We want to find out the integration from 0 to a. So find out where is a. 0 to a. Where is a? So we want to find out the integration from 0 to a. We want to go opposite. So that will be negative of a to 0. negative of a to 0, right? Because we're going opposite. A is less than 0. So which can be written as, we can write down this statement. This is problem, I think it's a problem 13. Since a is less than 0, so we can write down this integration of f of x dx, because we want to start from something smaller, but we can always change the limit of integration by putting the negative sign in front. So now it becomes a to 0. So now when we try to find out the integration of this function from a to 0, look at the graph. A to 0 means this area, which is a, and this area, which is minus b, because it's under the x-axis. So a is 1324, b is 2457. So you have to subtract b from a, which is what is that? If I subtract b from a, this number is the same problem. B is 2557, so that's negative, and A is 1324, that's positive, because we want to find out integration from a to 0, negative integration. So this is basically negative a, negative b. Here will be negative because the b is below the x-axis. So now if we plot the value, if we put the value of a, which is 1324, minus b, which is 2457, so eventually it will be positive. So 2457 minus 1324, 2457 minus 1324, that will be 113. So that is negative 113, but because of this negative, it will be eventually positive 113. So I'm going to use that one here. What happened? I don't know what happened. Did I do something wrong here? So a is the area under the curve from a to b. Okay, and this is the 0. This is the 0. So a is area under the curve, and b is area under the curve, this one. So when we try to find out the integration from 0 to a, I just switch it to the a to 0. So the area a minus the area b, which is a is 1324 and b is 2457. So did I do something wrong here? 2457, 7 minus 4 is 3, 5 minus 2 is 3. So 4 minus 3 is 1, so it's 133. That should be the case. Okay, b is 2457, a is 13. Zero to a. Yeah, it's supposed to be 113, but I don't know what happened here. Let me just put negative sign here and let's see what is going on. Let me just check it here. Okay, my bad. I found the error here. While I subtract the value 2457 minus 1324, I missed the one here, so it would be 1113. It would be 1113. That's the right answer. Okay, let's go to the next problem. This is evaluate definite integral. So we can use a fundamental theorem here. So I'm going to just do one problem and then skip the similar kind of problem here. Remember, integration of f prime x dx from a to b is f of b minus f of a. So as you can see that this f is antiderivative of f prime. So after finding the antiderivative, you have to find the value of that function f at b and minus the value of the function at a. So in this case, in this particular problem 14, uh, the antiderivative of 5x is this capital F of x is 5x squared divided by 2, because that's the antiderivative of 5x by using the power rule. So now by using the fundamental theorem, we need to find out f of b, which is f of 2, which is 5 over 2 times 2 squared, which is 10, and then f of a, which is f of 1, which is 5 over 2 times 1 squared, which is 5 over 2. So by using the fundamental theorem, the answer would be 10 minus 5 over 2, which is basically 2.5. 5 over 2 means 2.5, so it's a 7.5. So the answer here is type an integer or simplified fraction. So no decimal. So 7.5 means it's a 15 divided by 2. That's a simplified fraction. 15 divided by 2. Right. We can use the same idea here, use the fundamental theorem, find out the antiderivative of x squared, which is x cubed over 3, and find the value of that antiderivative at 4 and 3, and find the difference between them. I'm going to skip it for you. This is exactly the same problem. This is definite integral. So find out the antiderivative of 2x cubed plus 7. And then I'm going to do this one for you. This is problem 16. The antiderivative is capital F of this function is 2 times x to the power 4 over 4. That's by power rule, plus 7 times x, because the integration of antiderivative of 7 is 7x. So which is eventually x to the power 4 over 2 plus 7x. Now we need to find out the value of capital F at 4, which is 4 to the power 4 over 2 plus 7 times 4, which is eventually 64 times 2 is 128 plus 28. It's 156. That's f of 4. And then f of 3 is 3 to the power 4 plus 2, 7 times 3, which is oh yeah, so what is this? We can find out this value. This is type an integer or simplified fraction. So this is 3 to the power 4, which is 81. 81 plus 7 times 3 is 21 times 2 is 42 divided by 2. Just make the same denominator and then simplify. It is 323 divided by 2. That's a simplified form, 123 divided by 2. So that's the answer. Okay, what did I do wrong here? I did something wrong. So let me go back here. So integration of this one is 2x to the power 4 over 4 plus 7x. So that is basically x to the power 4 over 2. And now we need to find out the value of that antiderivative at 4, which is 4 to the power 4 over 2 plus 7 times 4, which is 128 plus 28 is 156. So another one is what did I do? Oh, I forgot to subtract. Okay, what is happening here? I forgot to subtract. I put this as answer, but that's not the answer. The answer is coming from fundamental theorem, which is f of 4 minus f of 3, which is f of 4 means it's 156. 156 minus f of 3 is 123 divided by 2. And now just make the same denominator. So that would be 312 minus 123 divided by 2, which is eventually what is that? So subtract 123 from 312. That will give you what is that? 189. 189 divided by 2. So that will be our answer, 189 divided by 2. Okay, so I forgot to use the fundamental theorem and I just used this one, so that's why the answer was wrong. That's problem 16. Let's go to problem 17 one more time. This is a definite integral, and this time we have to use a substitution method. So just substitute u equal x squared minus 144, and then find out the derivative du, that would be equal 2 times x times dx, and replace this x dx by du over 2. And eventually this problem will be square root of u times du over 2. And after finding the integration, put x equal 13 minus x equal 12. This is exactly the same idea, so I'm going to skip it. Okay, a defense contractor is starting production on a new missile control system. On the basis of data collected during assembly of the first four control systems, the production manager obtained the function below for the rate of lever use. Approximately how many lever hours will be required to assemble the fifth through ninth control units? Hint, let A equal 4 and B equal 9. A equal 4 and B equal 9. So set up the definite integral. So that means just use this function here, which is 1200 x to the power negative half. If you find out the integration of this function, that will give us the value of L, the required number of lever hours. So we need to find out the number of lever hours. Okay, so for this problem, so for finding the lever hour, we just have to, oh, where is that, we just have to find out the integration of this function. So the integration is, this is problem 18. The function inside here, the antiderivative of that function is, let's say f of x, which is 1200, and then by using the power rule, that would be x to the power half over half, and if you flip it, that will be 2400 x to the power half. So we need to use the fundamental theorem. So we need to find out f of 9 minus f of 4, which is eventually 2400, 9 to the power half, which is the square root of 9, 2400, 9 to the power 4 to the power half, which is basically 2400. Square root of 9 is 3 minus square root of 4 is 2, so it's eventually 2400 labor hours. So if we just use 2400 here, that will give us a right answer. Okay, find the area bounded by the graphs of the indicated equation over the interval. So plot the graph, and then find the area by using the integration. So what is that? So for the first one, as you can see that this is a parabolic graph, y equal negative x squared plus 16. So when x is 0, the y is 16. So that would be the graph of y equal negative x squared plus 16. That's a parabola. Y equal to 0 means y equal to 0 means y equal 0 means this x-axis, that's the y equal 0. This is y equal 0. And then finally x is from negative 3 to positive 3. So if you go here, you can find out this is negative 4 and this is positive 4, but we want to go from negative 3 to positive 3. So we want to find out the area of this part. So to find out that area, we just have to find out the integration from negative 3 to positive 3 y dx. What is the y? Y is negative x squared plus 16. So we need to find out the integration of negative x squared plus 16 dx from negative 3 to positive 3. So remember, this is actually, this negative x squared plus 16 is even function. So that means instead of finding the integration from negative 3 to positive 3, we can just say we are going to find the integration from 0 to 3 and then multiply it by 2. We can also do that. Okay, now let's find out the integration here for this one, the integration, and then use the fundamental theorem of calculus here. That will be 2 times the integration is negative x cubed over 3 plus 16x, and put value 2 first time and then minus 0. So whenever you put 0, everything will be 0, so you don't have to worry about the 0. Just put 2. Negative 2 cube over 3 plus 16 times 2 minus 0 minus 0. So you don't have to put that thing. If you try to simplify this and also look at the instruction you have, the area is, okay, what is the area? So let's find out this. This is 2 times negative 8 over 3 plus 16 times 2 is 32, so we can make it same denominator by multiplying top and bottom by 3. Eventually there is a 2, so there is a negative 8 plus 96 divided by 3, and then finally that will be 2 times, what is 96 minus 8? It is a negative positive 88, right, over 3. So if you multiply 2 times 88, so which is 176 divided by 3. So the answer for this one is 176 divided by 3 square unit, right? Okay, I did something wrong here, so let me go back and check what did I do wrong. So this is the graph of negative x squared plus 16 y equal to 0 is this one, and we want to find out the integration from negative 3 to positive 3 when x is negative 3 to positive 3, which is basically integration under this curve, the area of this curve. Negative 3 to positive 3, y is negative x squared plus 16, and if we try to find out the integration of this thing, so that will be what is that, negative x cubed over 3 plus 16x, and if we put oh, you see that the mistake I did here, instead of 3 I put 2. That is the huge mistake. This should be 3. The limit of integration is going from 0 to 3, so I need to put 3 here, not 2. That's a big mistake I did. Okay, so luckily I'm not doing the actual exam, I'm doing the practice. So negative 3 to the power 3 over 3 is 3 square, so that is actually negative 9, and it's actually 16 times 3 is 48, so that's 48. So 48 minus 9 is 39, right? That's 39. So 2 times 39, 2 times 39 is, it's 78. So the answer should be 78. 78. And look, that's correct answer. Let's go to the next problem one more time. Just plot the graph of this cubic function and then bound it from y equal to 0, and it'll find the limit of integration from 0 to 2, and then that will give you the area. Okay, so it's not a big deal, it's very similar to the previous problem, so I'm going to let you do this. Next problem, find out by looking the graph, choose the right definite integral. So set of a definite integral that represents the indicated shaded area over the interval AB. So we want to you know, find the area from A to B, this area. So the integration would be the upper function, which is f of x. Is that f of x? No, the upper function, which is m of x, minus the lower function, which is f of x, for on this interval. So it's a mx minus f of x, mx minus f of x from A to B. That will be mx minus f of x from A to B. That will be perfect. Correct. Okay, set up an indefinite integral that represents indicated shaded area over interval AB. Yeah, we did that. Check answer. Yes, correct. So next is find the area bounded by the graph of the indicated equation over the given interval. Y equal x squared minus 1. This is again integration problem like problem we did here. This exact same problem. Draw the graph of x squared minus 1, which is parabola. Okay, which is parabola, and then y equal 8. So let me just draw it here. So this is problem 22. Y equal x squared. This is the graph y equal x squared parabola. This is x equal -1 and this is x equal +1. And now y equal 8. Y equal 8 is, let's say this one is y equal 8 and x equal to 0 to 3. So x equal to 0 is this one. So I'm going to use different color here. Okay. So x equal to 0. X equal to 0 means this line. This is x equal to 0, and x equal to 8 would be, x equal to 3 would be line passing through this point. Why is that? Because when x is 3, the curve y equal x squared minus 1 gives you 3 squared minus 1, which is 8. So when x is 3, the y value would be 8. So we want to find out what is that? Find the area bounded by the graph of the indicated equation over the given interval. So we want to find out the area, from here to here, this area. Okay, and this can be found by finding the integration from 0 to 3. The upper function is 8 and the lower function is x squared minus 1 dx. We can always find the area bounded by two curves by putting the upper function minus the lower function and then finding the integration. So here we can use we can simplify that. 8 minus x squared plus 1 dx. So 0 to 3, 8 plus 1 is 9 minus x squared dx. We can use fundamental theorem for finding the antiderivative here. So the antiderivative of 9 is 9x. Antiderivative of x squared is x cubed over 3. And then we need to put 0 to 3. So if you put 3, 9 times 3 is 27. 3 cubed over 3 is, again, it's 9. And if you put 0 here, 0 would be gone. So 27 minus 9 is 18. So that's the area between those curves. 18 is square unit. Correct. Okay. East culture is growing at a rate of this is the rate of growing, gram per hour. Find the area between the graph of the derivative function, this graph, and the t-axis over the interval 0 to 10, and interpret your results. The area under the curve round to the 3 decimal place is, so we need to find the area. Okay, so in this problem we need to find out the integration of this function from 0 to 10. So this is very similar problem, like this is problem 23, because we need to find out the areas. So where is that? My pen is not working. So just give me a second here. So find out the integration of 0.2. This is problem 23, integration of from 0 to 10, 0.2 e to the power 0.08 t dt. If you try to find the integration by using the fundamental theorem of calculus, this is e to the power 0.08 t over 0.08, and then 0 to 10. Put t equal to 10 here. 0.2 over 0.08, t equal to 10, which is 0.08 times 10, which is 0.08, minus t equal 0, which is e to the power 0, which is 1. If you use your calculator, here I use the old form of calculator, and that gave me 3.06385, and if you have to round it to the 4 decimal place, it would be 3.06 what is that, 063 064 064 064. And then this means that total weight gain over the 10 hours will be 3.064, because the integration from 0 to 10 means it's a total weight, and that's right. Next problem, find the consumer surplus at a price level of P bar equal 120 for the price demand equation below. So this is the price and demand equation. The price is equal to 500 minus 0.05, and then we need to find, okay, for finding the surplus value, there is a formula we need to use, and the formula is we need to find out the consumer surplus, which is, this is problem 24. Consumer surplus can be found by finding this integration of d of x minus p prime of dx. So here x prime means whenever you put p prime value in the given price demand equation, so that p prime equal 500 minus 0.05 x prime. So if p prime is 120, so if we solve this equation for x prime, just solve for x prime, so x prime would be 7600. Just solve that and put that 7600 here, and then value of dx, and then p prime, and then find the integration. So that will be, you have to find the integration from 0 to 7600, 500 minus 0.05 x minus 120 dx. That's what we have given here. P prime means 120. So if you just simplify this, it would be 380 minus 0.05 x dx. Now we can find out the integration by using the fundamental theorem. So which will be so the integration of that is 380 x minus 0.05 x squared divided by 2, 0 to 7600. And if you put x equals 7600, what is that here? Okay, here if you put x equals 7600 here, that will be 380 times 76 minus 0.05 divided by 2 times 7600 square. If you use your calculator to calculate this value, it will be 100 and okay, let me just use my Wolfram alpha. So 380 times 7600 minus 0.025 times 7600 square. So this is 0.025. That gives me, using my calculator here, you can use your scientific calculator, that gives me 1,444,000. So 1,444,000. So 1,444,000. So that is the consumer surplus I get. Okay, so you have to keep in mind, this is the formula you have to use for the consumer surplus. Okay, let's go to the next problem. And next problem is also very similar to the consumer surplus, but this time it's a producer surplus instead of consumer surplus. So here you have to use another formula, and then the formula would be very similar to the previous one, but here I'm going to write down the formula. The producer surplus can be found by using 0 to x bar p bar minus s of x dx. Just find this integration and then you will be fine. If you go back to the problem here, um, p is s of x is given, p bar is given, which is 70. X bar can be found the similar way we found x bar in the previous problem. Put the value of x bar here, p bar here, and s of x is already given, and then find the integration the way we found the integration for consumer surplus. Here, exactly the same way you can find out the producer surplus, but you need to use this formula instead of the previous one. Okay, and then I'm going to skip it for you, and that's the 25 question from practice test 3. In actual test there will be 16 question only, but very similar questions, so make sure you do this practice test a couple of times.